Tesla has invested a lot in its gigapresses and continues to do so. But do those massive machines give an edge over the competition, and how much edge? Tesla as a company is used to doing big things, which makes it not surprising that gigapresses would be found in its factories. These are huge by all standards, most likely dwarfing your apartment. A gigapress is a die casting machine among the most powerful ever built, with capacity of 61 kilonewton clamping forces. They weigh more than 400 tons and require more than 20 flatbed trucks to transport only one. They measure 20 meters by 7.5 meters by 6 meters. They are made by the Italian manufacturing group known as IDRA, and the company has enjoyed Tesla's patronage more than a few times, with what we heard to be current multiple orders yet to be fulfilled. Interestingly, even though the name Gigapress goes with Tesla's Gigafactory, the name was actually coined by IDRA. Tesla uses the Gigapress to make the chassis in its cars in single pieces. This means the automaker deals with at most 3 parts instead of more than 100 if it had followed the practice of bolting and welding stuff together like the auto industry has been doing since forever. A Gigapress works like just any other die casting machine, as they use a plunger to force hot molten metal into a mold that will be reused. The impressive difference is the scale at which a Gigapress does it. To keep a fair idea, take a plastic toy car for example. The cheaper ones are usually made with a single solid piece before the tires are tacked on. Now imagine the whole chassis of a car made in the same way, but this time made from metal. The chassis will be at most 3 pieces, comprising the front and rear sections joined by a battery pack structure. The making of a vehicle chassis with a Gigapress takes place in different stages. The preparation step involves spraying soybean oil into the mold, which is needed to make it easy to remove the finished chassis easily. This is important for the mold to be easily reusable. The metal is melted using a furnace external to the Gigapress. Tesla combines aluminum and silicone to make its chassis, which technically means it's an alloy. The alloy melts at around 850 degrees Celsius, after which the right amount is forced into the mold by the plunger. After cooling down to 400 degrees Celsius, the mold is opened and the chassis is moved by a robot into a pool of water for further cooling to 50 degrees Celsius. Lastly, the chassis will be checked for defects and rough edges trimmed, after which all the required holes will be drilled in by robots. Gigapresses require a lot of investments and space for installation, so Tesla must have seen the clear benefits before committing to them. The fact is, the Gigapress is a game changer in the auto industry. The most obvious advantage is speed because despite their great proportions, they work very fast. Per IDRA specs, the aluminum silicone alloy can go from molten metal to a chassis in less than 100 seconds. That's a blistering speed when you compare that to all the steps and labor involved in fabricating and then fastening more than 100 parts together. It simply means Tesla can make more cars than the rest. JP Morgan visited a Gigapress in action and came back impressed. They did some quick math using a cycle time of 4 to 5 minutes and estimated that a single factory with 10 Gigapresses running continuous shifts can produce 350,000 Model Y chassis in a year. And that is because the Model Y chassis require 2 Gigapresses. That figure goes up when the Gigapresses work closer to specification by the maker. The ones at the Fremont factory have actually been observed to complete the job in under 200 seconds, even though they are still being optimized. This means a new factory can easily make 100,000 units in its first year of production. Such huge numbers are basically unheard of in the automaking world. Remember, Tesla wants to make 750,000 vehicles this year, and 50% more next year. One of the not-so-secret weapons is the Gigapress. With Gigapresses firing away in Fremont, Austin, Shanghai, and Berlin, the target of more than 1 million vehicles doesn't look so unattainable. The next advantage of the Gigapresses is cost saving, something Musk is fanatic about. Despite the considerable initial investment, the cost of production per vehicle goes down as they eliminate lots of operational costs. For instance, a single Gigapress makes about 300 robots redundant as there is not much coupling or much lifting work to do, according to Musk himself. And that is saying something after the debacle of his push for a robot-powered production process for the Model 3. The Gigapresses actually cut down on space requirement by about 30%.
Manufacturing cost is much less. We see about a 30% reduction in the size of the body shop.
Which may be surprising given the large sizes of the machines themselves. But less space and less robots means a smaller maintenance budget. People will lose their jobs, but from an economic point of view, gigapresses make a lot of sense. Think about the logistics involved in making more than 100 parts in different locations, monitoring for quality and transporting them to the assembly plant. Tesla is able to avoid all that with its army of gigapresses. All told, the cost of making a chassis drops by about 40% when gigapresses are involved. Again, remember, Musk really wants to make a cheaper electric car. With all the cost reduction here and there, that $25,000 electric car may be looking more realistic. We are aware Tesla is setting up research and production facilities in China for the express purpose of finding out how to make a very affordable car. You can guess a gigapress is going to be among the first things to be installed. The cars themselves benefit from the single-piece chassis. For one, they are not plagued by defects inherent with welding and bolting parts together, like weak joints or misaligned parts. They also weigh less despite being structurally superior. This translates to more range for the same battery capacity. This basically means Tesla has found a faster and cheaper way to make better cars, overtaking its predecessors. Tesla continues to race ahead of the competition as it has placed more gigapress orders from IDRA. It will likely use a gigapress for its upcoming Cybertruck and semi-truck, even though more power will be needed to cast the former's steel structure. Musk revealed it would require an 8,000-ton casting press to make the pickup truck's rear body cast.
We're actually going to be using even bigger casting machines for the rear body of Cybertruck, so we'll be using an 8,000-ton casting press.
Interestingly, IDRA itself announced that an order for an 8,000-ton casting machine has been placed.
We have been able to secure the first order for an 8,000-ton die casting machine.
Without revealing who the client is, but it kind of gave itself away by revealing the gigapress will be used for making new energy vehicles by a leading global manufacturer, which points at Tesla. Apart from that, industry expert Sandy Munro, who famously criticized the number of parts in the Model 3, has been informed by sources that Tesla will be employing 11 gigapresses across its 4 plants, in what will be a massive scale-up. The Berlin plant will have at least one when it comes online this year. There is one each already at Fremont and Shanghai. Tesla really isn't the first automaker to employ castings, as Cadillac, BMW, and Audi have used them in their models, but none has attempted it at the mega casting level Tesla is doing. Just how the rest of the industry will try to catch up remains to be seen, but we know it is not an industry that jumps at the chance to change things, so Tesla may be able to hold on to its edge for a while. Even JP Morgan predicts that only new startups stand a chance of following Tesla's lead here, as they are nimble enough to adapt to changes. For now, the only other company employing a gigapress is located in South Korea and doesn't even make cars. Glovatech uses it to make components for its 5G telecommunication equipment. Our comment section is open. Space, the final frontier that is yet to be conquered by humanity. The race to make humankind a multi-planetary species is being led by SpaceX. Elon Musk was the first to envision what the next step to human progress was, target for human colonization. In 2017, when Elon first proposed this huge undertaking, his goal was to get the first boots on the ground on Mars by 2022. Since then, Elon has pulled back to a more realistic 2024 deadline to reach the red planet. Let's bore deeper into Elon Musk's insane new plan to reach Mars by 2024. After first revealing his plans to land on the red planet and colonize it, the first challenge Elon Musk faced was how to get people and cargo there. Mars is not really in our immediate neighborhood. It is on an average about a whopping 140 miles away from Earth. This is a huge distance to cover for a human-bearing rocket. Just to give scale to this distance, the Moon is about 240,000 miles away. But the silver lining to this is that Mars and Earth's orbits do come very close to each other periodically. This event happens every 2 years. The event is called a close approach when Earth and Mars are nearest to each other. At this point, the distance between our home and the red planet is about 33.9 million miles. The next close approach will happen in the winter of 2022, hence Elon Musk's original timeline for a 2022 target for the first mission to Mars. The windows after that will happen in 2024, 2026, 2028, and so on. With these goals and timelines in mind, SpaceX started the development of the big Falcon rocket. This would be a 180-foot tall spaceship, including 3 protruding fins that sits atop a 230-foot tall rocket booster. The plan was to make the rocket fully reusable and cut down the cost of each launch significantly. In November of 2018, the project was renamed from Big Falcon rocket to Starship. This is a 2-stage rocket and is composed of a booster stage named Super Heavy and a second stage, which is the Starship itself. Starship is currently being powered by its Raptor engines, which can produce a thrust of 2 meganewtons. Starship is designed with the ability to re-enter Earth's atmosphere and land on a designated landing pad. The spacecraft is also designed to be able to perform automatic rendezvous and docking operations, and on-orbit propellant transfer between starships. SpaceX's facility at Boca Chica in Texas is developing the current generation of Starship model SN-15, which has been named the Starbase, since it is planned to host the facility to mass manufacture SpaceX's Starships. The plan is to build 1,000 Starships over 10 years, once the facility starts its mass manufacturing process. That is around 100 Starships every year. Elon Musk in January revealed he had plans to get 1 million people on Mars by 2050. To achieve this ambitious goal, he has plans to launch at average 3 Starships a day. But before we talk about colonization, let us look at the first manned mission to Mars. We've already successfully landed unmanned missions to Mars. In fact, our first successful landing was in 1971 when the Soviet Union's Mars 3 mission landed on the Red Planet. Since then, we have had multiple Mars rovers roaming the Red Planet collecting scientific data, but transporting a human crew and back from Mars is a whole new challenge. The first obstacle is the time, since the distance to the Red Planet is very large. This means very long mission times for the human crew to be shut inside a cabin being hurled through space. The shorter Mars mission plans have round-trip flight times of 400 to 450 days. These can even be cut shorter with 245-day round trip by using on-orbit staging methods. These are still very good periods to sustain living conditions for the astronauts. SpaceX's crewed Mars flight looks something like this. Phase 1. Starship launches with Super Heavy booster. Booster separates after delivering Starship to orbit and returns to Earth for future reuse. Phase 2. Starship enters Earth's orbit while a refilling tanker launches to mate with Starship in orbit. Starship then uses tanker vehicles, especially the Starship spacecraft minus the windows, to refill the Starship spacecraft in low Earth orbit prior to departing for Mars. Refilling on orbit enables the transport of up to 100 tons all the way to Mars. Tanker, after refueling, returns to Earth for future reuse. Phase 3. Once Starship has been fully refueled, it will begin its journey from Earth orbit around the Sun and onward towards Mars. Phase 4. Landing on Mars. Starship will enter Mars's atmosphere at 7.5 kilometers per second and decelerate aerodynamically. The vehicle's heat shield is designed to withstand multiple entries. Now that humans have successfully landed on Mars, what is next? The details on this are a little foggy. Initially, missions are planned to be Mars sample return missions, meaning the human crew would not be permanently staying. Rather, they would stay for a few days and return. SpaceX has not revealed if they would be retrofitting Starship as a livable space for the astronauts during their stay on Mars, or if they would be deploying some kind of habitat to support the exploration mission. NASA has a few proposals for deep space habitats, and SpaceX routinely organizes competitions for people to submit their proposals for an ideal habitat. The Orion Multi-Purpose Crew Vehicle, MPCV, being developed by NASA is intended to serve as the launch or splashdown crew delivery vehicle with a deep space habitat module providing additional living space for the 16-month-long journey. NASA also had a proposal for the Deep Space Transport, DST, also called Mars Transit Vehicle. It would be a crewed interplanetary spacecraft concept by NASA to support science exploration missions to Mars of up to 1,000 days. It would be composed of 2 elements, an Orion capsule and a propelled habitation module. But these are just proposals. We will have to wait a little more for SpaceX to slowly roll out the details for the first manned mission to the Red Planet. After human crews have made their first few rounds from the Red Planet, the time will finally come to start establishing a permanent human presence on Mars. When the colonization phase begins, SpaceX plans on average of 3 Starship launches a day. With a goal of transporting 1 million passengers to Mars by 2050, SpaceX initially has a plan to maintain a fleet of 1,000 Starships. Could hypothetically transport about 100 megatons of stuff to Mars. With each ship ferrying about 100 passengers, that would make for a total migration of about 100,000 people per year. SpaceX has proposed that it will start its plan for colonization of Mars by developing a high-capacity transportation infrastructure. This will involve transporting material and equipment to Mars to lay the ground for a sustainable outpost. Then, they plan to develop the rapid turnaround launch landing mounts for Starships to land and launch from. After that, SpaceX will set up local production of rocket fuel on Mars via in situ resource utilization, ISRU. In situ resource utilization, ISRU, basically means the collection, processing, storing, and use of materials found or manufactured on other astronomical objects. In our case, using abundant local resources on Mars like frozen water. In situ resource utilization could provide materials for life support, propellants, construction materials, and energy to spacecraft payloads or space exploration crews. After we successfully establish a permanent and sustainable presence on Mars, the mass colonization phase begins. This will involve hundreds of thousands of people moving to the Red Planet to set up habitation and exploit Mars's natural resources. Humans would have truly achieved their goal of being a multi-planetary species. And this may all be because of one man's insane plan to colonize another planet. Elon Musk's Boring Company has been around for a while. Its goal is to transport lots of people through underground tunnels. But is the company living up to the expectations it set? To answer that question, we will take a trip down memory lane and examine what Musk promised to achieve with the Boring Company, the criticisms, and use the recent test run at Las Vegas Convention Center to evaluate its performance and prospect. The whole concept started as a meme posted by Musk in 2016, in which he tweeted his frustration at the traffic in his city. He said, "Traffic is driving me nuts. I'm going to build a tunnel boring machine and just start digging." Moments later, the CEO tweeted he had thought about it and was actually going to do it. He revealed the company would be called the Boring Company. The concept took on life when Musk registered the Boring Company and acquired a 400-foot-long boring machine known as the Nanny and immediately began boring on SpaceX premises in February of 2017. The boring hasn't stopped since, and part of the result is the open trial of a Boring Company tunnel in Las Vegas recently. There is another tunneling going on under SpaceX's parking lot in Hawthorne, California. The stated purpose of the Boring Company is to solve the problem of soul-destroying traffic by building a network of rapid transport corridors underground. That may sound very ordinary and boring, as you are probably one of the millions that took an underground train to work today. However, Musk was not just digging tunnels, as he fleshed out his dream mass transport scheme. The visionary imagined pods that look like what you see in sci-fi that can carry up to 16 passengers at a time, hurtling through a network of tunnels at 150 miles per hour, completely autonomous. We get a glimpse of Musk's vision in a concept video released by the company, and it looked far out in the future. We see a red car that looks a lot like a Tesla going through street traffic on its own before coming to rest on a metallic platform that descends lower into the bowels of the Earth. Next, we see a crisscrossing of underground highways that look like magnetic rails, with vehicles moving at high speeds. There are more public transport vehicles with some shaped like big glass rectangles that can carry more passengers at once through the tunnel. The construction of the tunnels with all the futuristic elements is supposed to be economical. The proposal submitted by the Boring Company to the city of Chicago during its contest for building a high-speed transportation network is more realistic but still high-tech. The city wants to move people rapidly from downtown Chicago to the O'Hare Airport. The Boring Company offered to cut the ride to 12 minutes using a loop system of pods departing every 30 seconds with speeds of 150 miles per hour. The biggest criticism has been safety, which is not unjustified as the Boring Company wants to put people many feet below the ground surface. A look at the proposed Baltimore to Washington, D.C. tunnel gives us a new safety perspective on Musk's tunnels. At 35.3 miles, the underground corridor would be the longest non-rail tunnel in the United States. Bear in mind that there are no federal regulations for underground shuttles like the one the Boring Company is proposing, so local authorities apply. The tunnel will use modified Tesla vehicles that will be powered by batteries that will take off every 30 seconds and move autonomously in either way, with speeds again at 150 miles per hour, making the journey just 15 minutes long. In the future, Musk wants to introduce pods that zoom at 600 miles per hour. Even with the battery-powered vehicles the Boring Company wants to use, fires are a real hazard that has to be accounted for. The company's proposal states there will be fire detection, suppression, and safety measures, but its emergency escape plan doesn't really impress much. The proposed passenger emergency exits are spaced 10,500 feet apart. In comparison, the Gotthard Base Tunnel in the Swiss Alps, which is the longest underground tunnel in the world, has emergency exits at 1,000 feet intervals. The Boring Company's plan is even 4 times the maximum distance permitted in the National Fire Protection Association standards for public rail and transit systems, meaning escaping passengers may have to face a 2-mile trek through smoke to locate an exit. Musk's underground tunnels have been panned for the cost involved. Tunneling is expensive, even before adding the cost of the bells and whistles the Boring Company is adding. For example, the tunnels at the Las Vegas Convention Center cost $52.5 million and is expected to be free. The tunnel proposed for Chicago will gulp $1 billion. It is important to answer the question of who bears the costs. Another contention is whether the underground tunnels are really needed and what new things they bring. Underground travel already exists. Emissions-free underground travel already exists. Fast urban mass transit already exists. The cool factor? Unnecessary. So why dig new underground roads at such a high cost? Other criticisms include the claustrophobic effect on passengers that may find the narrow corridors choking, a concern which has largely remained unaddressed by the company. Lack of detailed consultation with property owners that may be affected. Even when costs and safety are no issues, there remains the question of if the Boring Company can deliver on its promises. Good enough, the recent public trial of the loop at the Las Vegas Convention Center answers part of that question. The system, known as the LVCC loop, consists of 2 tunnels and are set to open in June. Instead of autonomous pods we expect, the testers were ferried in a few dozen Tesla cars that include the Model 3, Model Y, and Model X. Not surprisingly, they were driven by actual humans rather than advanced AI. And rather than the advertised dizzying speeds of 150 miles per hour, the electric cars moved at a sedated pace of 40 miles per hour along the narrow corridors. Unlike the 30-second intervals promised between takeoffs, passengers were seen waiting up to 5 minutes for a ride. And there was no smartphone app to book rides either. There was congestion, one of the very things the tunnels are meant to fix, in the underground stations as the test vehicles had to maneuver around other cars and people to exit and re-enter the tunnel. There was also general confusion as riders tried to figure out how the system works. The biggest question from the trial is whether it can handle the 4,400 people per hour as planned by the Boring Company, and if it would be able to reach the 150 miles per hour as advertised. Documents already show that the passenger capacity has been adjusted down to 1,200 riders per hour. The tunnels will also rely on human drivers for the foreseeable future, who may not be able to drive at high speeds in the narrow tunnels. The whole show was basically hundreds of people being driven around underground by a couple of Tesla cars at limited speeds. The Boring Company hasn't actually translated its exciting graphics-packed concept videos and artworks to reality. However, that has not stopped it from attracting both investors and potential clients. A representative of the Boring Company claims that they get about 20 inquiries per week from counties and municipalities all over the country. Clearly, the idea of rapid underground transit can work, but we are still a far way out from the futuristic concepts presented by the Boring Company. Have you lowered your expectations of the Boring Company, or do you still expect some magic in the near future? We would love to hear you in our comments section below, and any suggestion you might have for us